All right, hello, boys and girls. We're going to be reviewing statistics at this point. This can be well, it's technically the 11th unit, but it says 10th unit here, so I apologize. If you so choose, you can change that to 11. Okay, so a couple big things we're going to be reviewing here are mean, median, and how to choose what to pick, whether the mean or the median. We'll also talk about range. Let's start with the mean, which is the measure you would find, the measure of center you would find if the data that you've collected has no outlier. Now, how can you tell there's no outlier? Well, look at these temperatures for 5 days in late May, and you'll see that they're all fairly close together. Now, the 87 is slightly farther away than the 84, but again, they're very close together. So if there was a temperature maybe in the 20s, that would be an outlier. Or if there was a temperature maybe in the low hundreds, that would be an outlier, but these temperatures are pretty close together. That's why we're going to find the mean. So to find the mean, we're going to add up all the data points. 83, well, there's two 83s, so I'm actually going to do 83 times 2. You could add these up individually, but since there are two 83s, I'm going to add that one up separately using times 2. And notice I'm crossing the numbers off just to make sure I've included each one. So I'm going to add these up, and I'm going to divide by how many numbers there were, and there were 5. So I'm kind of adding up all the temperatures, all the degrees, and then splitting them evenly, or dividing them up evenly across 5 days. That's what this is. So to find the mean, we'll add them up. Plus 84, plus 87, plus 81. Now when you add up the numerator, the numbers in the numerator, you get 418 divided by 5. Now, when I divide by 5, I'm going to expect the number to be in the 80s because all these temperatures are in the 80s. So if I get a number that's really far above the 80s or really far below the 80s, I'd be concerned because the mean is meant to measure the center of the data. So the number we get here should be around the center of the data we have. And the number I got makes sense. So it's 83.6 degrees Fahrenheit, which, if you look at the rest of the data, makes sense because it's around the middle or the center of the data. This next question is a little different because it's asking us to find the median. So when we find the median, what we have to be really careful about is making sure to line up the numbers from least to greatest. So we can't just take the numbers as they are right now and find the middle number because they're not in order from least to greatest. So again, the median is also a measure of center. We want to find the middle of the data, the center of the data. And to do that, we need to line the numbers up from least to greatest first. So the number with the least value is 46. Cross that off. Looking for the next one would be 52. 52. Crossing that off. It looks to be 54. And then 55. 56. So this is the ages of the last 9 presidents, it looks like. Okay, 61. 64. 68. And then 79. Now, before finding the center number, let's think about how many numbers we're dealing with, because that might give us an indicator of, like, are we going to have 1 in the middle or 2 in the middle? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. Since that's an odd number, we're going to have just 1 number in the middle. So what I'm going to do is I'm going to cross off the least and the greatest until we get to 1 number in the middle. And then we'll stop. That number in the middle is 56, so the median is 56 years old. It's the median age for the last 9 presidents. All right, let's look at this data below here. It's pull-ups per day. So you can take a look at the data. You can see that there's a variety of push-ups being done every day, or pull-ups, I'm sorry. And if you look at the data, there's one number to me that stands out, and that is this 80. So all the numbers are fairly close together. I mean, the 2 is a little bit, a little bit low, but the 80 is so far away from all the other data points that shows me that there is an outlier. This is an outlier. It's a number that's an extreme value. It's really far away. So which measure of center would we use to represent this data? And because there's an outlier, we're going to use the median, because the outlier won't affect the median as much as it would affect the mean. So we will use the median because there is an outlier. If we were to find the mean would be pulled up by the outlier. That's why we wouldn't use the mean here. Now, just for practice, there should be some room here on this line. We're going to find the median here. So we'll start by ordering the numbers from least to greatest. We have 2, crossing it out. 7, crossing it out. 8, crossing it out. 12, then 15, 19, and then last but not least 80. So you would include the outlier here just because that is a data point. All right, same method as we used with the president age one. We're going to cross them out. Now we do have 7 data points, which is an odd number, which means we'll have 1 in the middle. And there it is. The median number of pull-ups would be 12 for this set of data. Okay, let's take a look at another set of data, and this is a bunch of basketball players here, from Michael Jordan all the way to Kurt Rambis. So this is the average points per game for each one of these players. You can see that there's a, the least amount of points per game would be Kurt Rambis, with 5, which is certainly more than I could probably get in an NBA game. And then we have all the way up to Michael Jordan, who had 30. So it says, what is the range? Now, remember, the range is the greatest data point minus the least. So if we look at the data, which data point is the greatest? It was Michael Jordan, who averaged 30 points per game. And then we'd also look at the least, which was, of course, Kurt Rambis. So we're going to subtract. Now, Kurt Rambis didn't have like the lowest of all time, but just within this data set, he had the least number of points per game. 30 minus 5 would be 25, so that would be the range. Now, what does the range show? The range shows how spread out the data is. How spread out the data is. So the mean and median are called measures of center. They're trying to find the middle of the data. The range is called a measure of spread. It's supposed to show you how spread out the data is. So the 25 tells us that these players are pretty spread out from the greatest to the least. That's a wide margin. If the most was 30, 25 is a pretty high range. All right, last but not least, let's look at this collection of data here. We have a line plot that is titled Weekly Chores. And you can see here that maybe these are students being asked how many chores they had each week, and that data was collected, and they used a line plot to show how many chores the class would do as a whole and individually. So it says find the mean of the data set. And why are we finding the mean? Well, if you look at the data, there's no outliers here. All the numbers are really close together. So we're going to use the simplest way to find the mean, which is not to add up each point individually, but to use multiplication to help us add up the data points more efficiently. And we're going to round to the nearest tenth if we need to. All right, so let's add up all the data points first. We have 2 zeros. It's going to be 0 times 2. Plus, we have 5 ones. It's 1 times 5. Let's see, we have 1, 2, 3, 4, 5, 6 2s, which is the peak of the data. Whoops, shouldn't have said that. We have 3 3s, so we're going to do 3 times 3. And then we have 1 4. You could write 4 times 1, but I'm just going to write 4 because there's only one of them. And we're going to divide this by how many data points there are. So to figure that out, we'd have to count each individual data point, which are the x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm thinking we're going to get a pretty weird decimal unless it works out to a number like 34 or something. Let's see here. Okay, so we have 0 times 2, which is 2, plus 5, plus 6 times 2 is 12, plus 9, plus 4, 32. So again, this is a measure of center, the mean. So when we find this answer, it should be around the center of the data. And to me, that's around, 2-ish, maybe more toward 1, maybe somewhere between 1 and 2. That would be the center of the data. So if we did this and we got a number like 12, that wouldn't make any sense because the data isn't centered around the number 12. All right, 32 divided by 17 is going to be a long decimal here. We got 1.882 something. So it says round to the nearest tenth. So this 8 is in the tens place. We're going to round to the nearest tenth. This 8 will tell us that we have to round up. So our answer is going to be 1 9/10 chores. So what we might say is that the typical person in this class does a little bit less than 2 chores every week, which is not too bad. 2 chores, depending on the chores, I guess. All right, what is the peak of the data? So when we think of a mountain, the peak is all the way at the top. I did mention already what the peak was. Whoops. The peak here is 2 because it is it has the highest number of data points. It's the most number of data points. So the peak of the data is 2. Okay, so after watching this, if you have any questions about statistics or anything else in math, please let me know. If not, I hope you have a great day and hope to see you soon. Okay, bye-bye.